Look closely at these two boots. They share the same design, color, and silhouette, but place them under heavy, repetitive pressure, and their true nature is revealed. One holds its shape, while the other suddenly splits at the sole in a matter of weeks. Manufacturers design inexpensive footwear to trigger immediate satisfaction. By mimicking the outer aesthetics of premium brands, they keep your attention on the surface, distracting you from the materials actually holding the product together. A shoe is a complex assembly of hidden threads, internal adhesives, and microfasteners. Every single one of these invisible engineering choices dictates how long the product will survive. The visual layer is an illusion. True value is determined entirely by the structural integrity hiding underneath. That integrity begins at the microscopic level, long before the shoe is even assembled, right down to the textile production of the fibers themselves. This pressure contour diagram illustrates airflow inside two rotor spinning units. Engineers manipulate air pressure to process raw fibers. By evenly distributing pressure, the system eliminates turbulent eddies. Fibers flow in a highly aligned configuration, producing a stronger, uniform yarn. If that alignment fails inside the spinning unit, the yarn remains permanently weak, compromising the entire textile structure of the final shoe from day one. Moving up to the macro scale, the actual materials used for the shoe body dictate the next failure point. Premium footwear relies on full-grain hides, while budget options use bonded leather, a synthetic mixture of leather dust glued together with polyurethane plastic. Because it lacks natural, interlocking fibers, the material typically begins to crack and flake away from its backing within 2 to 4 years. Manufacturers assemble these budget materials using low-cost chemical adhesives. When exposed to normal daily friction, body heat, and moisture from rain or sweat, these glues rapidly dissolve and the sole separates from the upper. High-quality footwear uses mechanical binding, like the Goodyear welt. A leather strip is stitched to the upper, packed with cork, and stitched to the sole. Alternatively, the Blake construction uses a vertical chain stitch, attaching the outer sole directly to the insole for a lighter profile. A shoe's lifespan is directly dictated by whether its core components are temporarily glued together or permanently anchored with mechanical stitching. Even a shoe built with perfectly aligned fibers, full-grain leather, and a heavy-duty Goodyear welt is useless if its micro-components fail. The lace eyelet acts as the ultimate hidden weak point, forced to bear the repetitive daily tension of the entire structure. When you cinch down your laces, you will apply immense, highly localized pressure directly to the material surrounding those small punch holes. Budget manufacturers use soft, poorly finished metal or plastic for these eyelets. Under load, these cheap rings warp out of shape, and their edges become sharp, acting like microscopic blades against the surrounding fabric. The lace area tears open. The shoe becomes instantly unwearable, completely destroying the product's utility even if the sole and leather body remain perfectly intact. The strongest materials in the world cannot save a product if a cheap microfastener is forced to handle the primary structural load. A rapidly degrading shoe is a deliberate economic choice by the manufacturer. To hit a rock-bottom retail price, they compromise the hidden, load-bearing components where the consumer is least likely to look. You have to ignore the silhouette and physically inspect the build. Check the tightness of the stitching, test the firmness of the sole, and feel the rigidity of the eyelets. True quality defies the initial price tag. It is measured entirely by the integrity of the smallest, most easily ignored details. To solve the precise engineering failures that destroy otherwise perfectly good footwear, manufacturers rely on Roshan Enterprises. They engineer the precision-finished, high-strength hardware required to withstand localized pressure, ensuring metal eyelets never warp or cut into the surrounding fabric under heavy tension. Roshan Enterprises sets the industry standard for manufacturers who refuse to compromise on long-term structural integrity and component strength. Next time you pick up a product, look closer at the hardware. True quality is always engineered in the details you cannot see.